Okay, so in this video I'm going to find the second derivative of this parametric equation. From the last video, we figured out that we're going to use t equals 0 because it's much easier than using the actual point. We figured out the derivative of x with respect to t. We figured out the derivative of y with respect to t, and we figured out that to find the derivative of y with respect to x, we have to use the chain rule, just like we did here. And everything was all fine and dandy. We got a nice little answer. But the second derivative is a bit more disgusting. Actually, it's a lot more disgusting. Well, to find the second derivative, a lot of people would just say, hey, we can just, do exactly the same thing we did here. So what? The second derivative is this, right? Yeah, so what can we do? We can just use the chain rule, right? And instead of taking the first derivative on top and the first derivative on the bottom, we can just, do the second derivative. So that's going to be what? The quotient of, what's that? D squared y over dt and d squared x over dt squared. Okay. So a lot of people would think to do that, but that's not actually right. Ooh, it's gross. Yeah, it's a lot less intuitive than you'd think, and it's kind of unfortunate, but yeah. The actual the way to get the second derivative is like this. The second derivative, as we see here, the second derivative is actually just the derivative of the first derivative, right? So let's write it like that. The derivative of the first derivative, which is just dy dx. Okay, cool. So that looks neat, but then once we realize that both x and y are functions of t, as we figured out before, we have to use the chain rule, just like we did in this case, right? So now, in order to find the derivative of this, what we needed to do was we needed to take the derivative of the first, this y, the y function, with respect to t, and then we needed to take the derivative of the x function with respect to t. Okay? So the derivative of the x function with respect to t is just going to be dy dt. Sorry. So we can do that for this one too. The x function is just going to be dx dt. The y function is going to be a bit more difficult, because check out what happened here. We took the y function and we took the derivative of it with respect to t. But now here, look, now instead of d dx of y, we have d dx of this whole thing. So what's going to happen is, instead of taking the derivative of just this little guy with respect to t, we have to take the derivative of this whole thing with respect to t. Now, what does that look like? We're taking the derivative with respect to t of this whole thing. So it's a bit more gross. And once you realize that this right here is a quotient, yeah, you start to kind of throw up in your own mouth. So yeah, let's try and do this. I'm gonna try and do it all on one page, but I don't know if I'll be able to do it. Let's try. Okay, so the second derivative is, I'm just gonna actually start all the way over here. Okay, the second derivative is going to be d dt of dy over dx over dx over dy. Okay, so that's going to be the derivative with respect to t of the first derivative, right? What's the first derivative that we got? Well, I didn't write it down, but the first derivative that we got was actually negative sine t plus pi divided by 2 cos t. That's the derivative that we got from the other video. And that's going to be all over whatever dx well, actually that's supposed to be a t. Whatever dx dt is. What is that? That's just 2 cos t. Okay, so you heard me sigh because this is a quotient, and if we want to take the derivative of a quotient, we have to use the quotient rule. So let's do that. What is the quotient rule? The quotient rule says that in order to take the derivative of this, we have to take the derivative of the top times the bottom, 2 cos t, and then what we're going to do is we're going to subtract the derivative of the bottom, so d dt of 2 cos t times the top, is negative sine t plus pi. I'm sorry, there's a delay, so my writing looks like crap. Okay, so that's that whole thing over the bottom squared. So it's going to be 2 cos t all squared. Okay, that's this thing. And it's all over 2 cos t. Yay! So right away I'm just going to include this in the denominator so that I don't have to keep writing this denominator right here. So I can just take this, and it's the same as multiplying by the reciprocal of it, right? So I'll do that a bit later.